So howdy, this is Haley Lambright, Laura Schauer,
Henry Mercado,
Valentina Serrano,
Madison Darden,
Nicole Reisinger.
and this is the design of an alternative configuration of a closed-loop wind tunnel for acoustic measurement senior design team. So for the problem statement, currently in the Maestro lab of the aerospace department, there's no way to take acoustic measurements. The center test section is made of plexiglass, which causes a lot of resonance, reverberation, and sound echoing. And so anytime that they've tried to take any kind of accurate acoustic measurements, they failed. And so that is our job, is to come in and create a test section that provides an environment for them to take these acoustic measurements with.
So at Texas A&M, like Haley said, because they don't have that ability right now, our design and what we have brought this semester adds value to Texas A&M by giving new functionality to the lab. Now there will be opportunities to do acoustic and aerodynamic measurements inside of our wind tunnel. And this just brings new areas of research to partner with groups like NASA Langley or with Boeing, and hopefully bring a lot of new research opportunities to us. And ultimately, all of this is to enhance the design of different aerodynamic systems.
So as you can see through this CAD model, this is what our finished design looks like. There is one center test section and two side chambers. The side chambers are filled with acoustic foam wedges that are made of polyurethane, which is absorbing of acoustic noise. And then the center test section has a floor and ceiling made of composite walls, also with polyurethane foam. And then the sides of the center test section are acoustically transparent windows, which means the center is aerodynamically closed, as in air just flows through it and does not enter the chambers. But the acoustically transparent windows mean that noise enters the chambers, but like I said, not the air. And one of our big points of our design is that it is interchangeable for the lab with 3 separate pieces, which is not yet seen in anechoic chambers, and that it reduces noise up to 20 or 25 decibels.
During the spring semester, our team was able to take bass frequency and sound pressure level measurements. These measurements were used to compare to our final design and testing during that process. So our team was able to verify our design by testing it in the wind tunnel and compare it again to those measurements with the plexiglass test section. As you can see from the plot, there was a 10 to 20 decibel reduction, with the blue line as the the gray line as the plexiglass measurements and the blue line as the sound pressure level for our new design with the anechoic chambers. And so you can tell that it made a huge difference to add in those chambers, and it did have anywhere from an 8 to 25 decibel reduction as the team predicted at the beginning of the semester.
The current status of our project is that we have the center test section and the anechoic chambers built and assembled in the Maestro lab, and we have performed several tests to validate our